Okay, so I want to do number 25 and 16.2, which says I should integrate over the rectangle, and they give me some rectangle stuff. So x's are between -1 and 1, and y's are between 0 and pi over 2. And I'm supposed to integrate the function 5x squared plus 1 quantity times sine of 3y.
Double integral trick because they're two different variables.
Dope. Perfect. Thank you. Apply the double integral trick. First, write it as a double integral. Right?
Okay.
So first things first, I'm integrating d area, right? And so I think to myself, hey, d area could be like dx dy or dy dx. Pick your favorite order. Does it matter here?
No, it's a rectangle. It's pretty easy.
Yeah, it's a rectangle. It doesn't matter at all. Just make sure the order you put the dx dy in matches your integral order. Okay, so I'm going to integrate from 0 to pi over 2. Is that right? Did I write that down right? Yeah.
Oh, 3 pi over 3.
Okay, so it's pi over 3 in the book. So we're going to integrate from 0 to pi over 3, and then we're going to integrate from -1 to 1. The function 5x squared plus 1 times sine of 3y. And which order did I pick here?
dx dy.
The x bounds are on the inside, so dx dy.
Is there any reason you pick that order?
No,
Easier?
not at all.
Okay.
And then I should apply the double integral trick. Did you guys forget that?
No, I have it.
No. Okay. So the double integral trick says this crap is constant with respect to y. So I'll factor that out here. Right? So this is going to come out here. And then everything that's left, this, and this, is constant with respect to y. So that's going to come over here. So in the end, you'll end up with the integral of the x bits times the integral of the y bits.
Yep.
Right? So I'm going to have the integral of 5x squared plus 1 dx times the integral of sine of 3y dy. And now I just need to make sure that I don't screw up my bounds. So where do the bounds go?
-1 and 1 on the left, and 0 to pi over 3 on the right.
Perfect. The y bounds should go with the y stuff. The x bounds should go with the x stuff. You guys all good with this? And the only reason this thing worked, and I think this is what Railer's talking about back there, is that this was a function of x times a function of y.
And they're independent of each other. You can't have like.
Yeah, they're not entangled at all. If you had an x in here, you couldn't do this. If you had a y, like if you had 5x squared plus y, you couldn't do that. Right? So it only works when one thing is strictly a function of x and not y, and the other thing is strictly a function of y and not x. Yeah, and they're multiplied together. If they're added together, you're screwed. If they're divided together, you're screwed. I mean, you could rearrange that one, right? Okay, so you get to here, and then you have separated a Calc 2 or a Calc 3 problem into two easy, Calc 1 or Calc 2 problems. The only caveat here is that you need to what? Yes, you need to multiply them together when you're done. Slightly harder than that was,
I don't remember how to do that.
you guys maybe don't remember how to unchain rule,
Oh, right.
because it's been a while and you're probably a
I
little
think I
rusty.
figured it out when I tried.
Okay, so let's do this first thing.
5/3.
So here you got 5x cubed over 3 plus x evaluated from -1 to 1, right? So that whole jam. And then on this thing here,
Negative.
okay, yeah, I'm going to multiply. You guys remember?
Oh no. Oh no.
Oh.
PSD flashbacks.
Yeah, so remember when you're unchained ruling, that's U substitution. Did you guys know that? Is that how that was phrased to you?
Yeah.
We didn't.
Yeah.
We
When you
don't
need to
remember
back
us
out of the chain rule, you want the U substitution trick, not integration by parts, which is the U and the V thing.
Hold
This
on.
is just U substitution. So I'm saying let U be 3y. Then what's D?
Stop.
Okay.
There might be a good thing. Hold on. If this equals 0, then we don't even have to deal with it at all.
Du is 3 dy,
Yeah,
right?
I remember that.
And so you need this piece, and you need that 3. You haven't got it, so you need to put a 3 in here, which means I need a 1/3 outside. Did you guys learn that as solve for dy and then cram that in?
Yeah.
That's also fine.
I guess we could just learn it anyways. But
Yeah,
Yeah.
I'm really using this to refresh this.
I
Don't
know
worry
that
about it.
X side is 0.
Yeah, don't worry about it. Cool? You guys all good with this? So I got here 1/3 times the integral. I'm going to leave the bounds for a second. And this is going to be sine of u du. And then what are your bounds? Ooh,
No.
that's what I wanted.
Wouldn't you have to change them, of course, during USA, but if you actually change it back later on, do you necessarily have to change the bounds still?
No, so I don't care how you do this. So these bounds, this 0 and this pi over 3, those were y's, right? Those are y is 0 and y is pi over 3. If you want, you can write this as y is 0 to y is pi over 3, and then back substitute once you're done with the integration. I would prefer if you just changed them. Because it's easier here, because you, like, plugging 0 into
Oh, because then you end up with pi.
3y is 0. So this is a u bound, right? So this is the bound u is 0. And then this upper bound is going to be u is
Pi.
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 Because when y is pi over 3, 3 times pi over 3 is pi, u is pi.
So if you have the 1/3 on the side, then you also have the 3 next to dy. Is that just for demonstration purposes, or?
It works out the same. You
So
can-
that's, this piece became the du.
Well, when I,
Right? Those two things are the same. And so for me to get a du in here, I need to replace a 3 dy.
This is the constant.
You did multiply by 1.
Yeah, I multiplied by 1, right? To get that 3 so I could make it into it, that 3y, 3 dy into a du.
And that's part of the integral rule, so you pull the 3 out and then you have 3.
Okay, so hang on, wait. We're done because I'm integrating sine.
Yeah.
Sine goes like this, right?
Yep.
This is at pi over 2. This is at pi. Do you guys know how much area is underneath one of these? This is not 0,
No.
right?
Pi over 2 squared.
You guys
No, I
don't
wasn't
know.
saying that.
Okay, cool. Let's figure it out. So we have,
I wasn't saying the y side was 0.
so I've got
No, it's
5/3 plus 1, right? Minus all of minus 5/3
Minus
Oh,
one.
minus
Okay,
1.
mistake then.
Which, because we kept checking those parentheses, we know that's going to end up equaling 10/3 plus 2.
Okay. And then I need to multiply by this thing. So I got a 1/3 there. And then what's your sine of u?
That
Integral
pi,
is
Negative cosine.
negative cosine
Of you.
of u, right? Yes, maybe?
Yeah.
Are we sure? How do we check?
To the, just take the derivative.
Yeah, differentiate.
Yep.
Derivative of sine is cosine, the derivative of cosine is minus sine. Cool, there was a minus. Good. And I need to evaluate from
Pi to 0. 0, so we are pi. That's
0 to pi. So I got here 10/3 plus 2 times 1/3 times, this is the part where we find out how much stuff is underneath that bubble.
It's a negative 1, so 1 minus a negative 1.
The area under one of the little arches in the sines and cosine curves, they're 2. That's a super nice trick to know. Okay, so all told here, I got some thirds, like maybe
14 thirds should be, right? Before.
I got a 6.
That would be, no, I didn't.
Wait. That,
think 2 things is 6 things split 3 ways.
Times 2 ones.
Then times a third, then times 2. So this seems like I got 32 ninths.
Yep.
Okay? Which is what? Like, what's the interpretation of 32 ninths?
The signed area of that
That's the signed volume, right?
volume, duh.
Underneath this function,
no.
over top of
This integral.
the rectangle that I erased a long time ago. It's the minus 1 to 1 in the x and 0 to pi over 3 in the y.
Did you add the 16 thirds first half
Did I have, what?
for the?
Yeah, 16 thirds for the first thing.
Yeah.
And then the other thing was 2 thirds. And then I multiplied them. They're not even paying attention now that I finally.
No, I'm trying to find.
And then I multiplied them.
I'm trying to see what the actual answer was to see if that's right.
Of course it's right.
Well, I'm just double checking.
Yeah, and I done goofed. I accidentally added instead of subtracted.
You really, you,
But you
this
said-
little face.
You said it could be.
Oh yeah, totally. I make arithmetic errors all the time. It's good to check.